Hi there. Thanks for joining us on this edition of Space Nuts. My name is Andrew Dunkley, your host, and always good to have you with us. Coming up in this episode, we will be looking again at Ingenuity. It's all bad news, but not really. Plus the Slim Moon lander, which has landed on the moon, sort of. And we're going to talk about the passing of a great in astronomy and space science. There's a lot on today. We've also got a story about our Milky Way's dark matter halo, and it looks like it's got a weird thing going on with it that might make our galaxy unique, plus a potential explanation for the burping of Mars. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to talk about all that and a little bit more later on is Professor Fred. What's an astronomer at large? Hello, Fred.
Hi, Andrew. Good to see you again. Good to see you without a delay in the sound as well.
Yes. Long explanation, but my OneDrive was synced to the hard drive and they hated each other, basically. That's what the problem was. Short explanation for a big problem. But it's all sorted out now, so we can talk in real time, not like we were on a satellite phone for the last couple of weeks. Bizarre. And everything good at your end of the world?
It is, thank you. Yes, all going well so far. I can't believe that the year has taken off at such a high rate of noise. It seems faster every year. So yes, January's gone.
I read a study as to why the years go faster as you get older, and it's
Did you?
Yeah, and the answer is because we've experienced most of life, and we're not sort of being welcomed by new and exciting things anymore like when we were children. So for some reason, that just turns it into a very fast-motioned day by day at in the second half of your life.
So life becomes routine, is what you're saying?
That's what it is. Yeah.
I get that. I quite like routine, actually.
Me too.
Unlike my other half, who doesn't. But which is why she's constantly conjuring up these tours that we do to take people around to places where we've never been.
Well, if you want the year to seem like it's lasting longer, you've got to bring new things into your life, apparently.
Yeah. Yep.
Otherwise it just becomes routine and every day's the same. And
who would have thought Space Nuts would become routine?
Doesn't feel routine, and certainly something that wasn't routine was the situation with the Ingenuity helicopter. Now, we've been talking about Ingenuity the last couple of weeks because it had an incident. They thought they'd lost it. They found it again, but now it is end of mission.
Yes, because we know that it's suffered damage. And so the story is that I'm just trying to bring up the right page, even though I kind of know what the story is. Here we are. We've got a lovely picture of Ingenuity on my screen taken during its 54th flight. So flight 72, which was, I think we've spoken about before, was just meant to be an up and down hop to check that something that went wrong on the previous flight with its communications was okay. But it turned out that 70-second flight, something went wrong probably in the landing, and it broke one of the rotor blades, the two rotor blades that counter-rotate on top of Ingenuity. One of them is now broken off, and there's an easy-to-find photograph, actually, of the shadow of the rotor blade taken by one of Ingenuity's cameras. The shadow of the rotor blade on the Martian sand, and you can see the end of it looks as though it's not there. So that sort of essentially writes off the helicopter. It reached actually an altitude of 12 meters or 40 feet with a 4.5 second hover. So it was it was obviously in reasonable shape at that stage, but then when it landed, it looks as though something went wrong with the landing and it broke the rotor blade. And so it's now been deemed unusable after 72 flights compared with the expected 5.
Remarkable.
Astonishing, yeah. And it's covered 17 kilometers, a bit more than 10 miles in its couple of years of flying. Actually, it's
3 years.
Its first one was, it's nearly 3 years. April 19th, 2021 was the first flight. And you can actually go online, Andrew, and you can get the full flight log of Ingenuity. So, that's again, not very hard to find. I think it's such an astonishing achievement that this has been able to happen. That's been 3 really exciting years of Mars exploration. And of course, the lessons learned from that, because this was originally just a technology demonstrator. It's the idea is to just demonstrate whether you can fly a helicopter on Mars and attach cameras to it, and all of that has been proven absolutely positive. The information that we've learned from Ingenuity will be fed into the Dragonfly mission, which is another helicopter which eventually will go to Titan, scheduled for launch not very far down the track, 2028, 4 years' time. We'll be sending a mission to Titan with a helicopter on board to look at the thick atmosphere of Titan and have a look at the methane lakes and seas that there are there. It's amazing. Extraordinary what this will lead to. So, all credit to Ingenuity. RIP, what a wonderful mission. Had to come to an end sometime, but I think it's done pretty well.
Yeah, it's been fantastic. Now, closer to home, JAXA has sent a mission to the moon. It's the SLIM mission, which stands for, and I looked it up and now I can't remember, but...
Smart Lander Investigating Moon.
Yes. Now, they had a bit of a problem as well, and they have successfully landed on the moon's surface, but she's upside down.
That's right. And what's more, we've got pictures of it being upside down.
How did that happen?
So the landing was 20th of January. Everything went really well, but obviously during the last few seconds, something went wrong with one of the engines. Basically they've got downward firing engines that are slowing down the trajectory of the spacecraft as it gets near the moon, and basically you want the velocity to be 0 when it touches the moon's surface. Something went wrong with one of the engines, and that seems to have tilted it over, but it made a soft landing because they could communicate with it. And what they couldn't do, and I think we talked about this, the first hint that something was wrong was nothing coming through the solar panels. And the suggestion then was that something had happened that skewed the direction that the solar panels were pointing in, and they couldn't see the sun, which means, yes, bad news. And in fact, if you remember, do you remember Philae? That was the lander that went down onto the surface of Comet 67P, was that its name?
That's it, I think so.
Churyumov-Gerasimenko, which was a little lander from the Rosetta spacecraft. That had the same problem. It fell over when it landed, and landed in the shadow of a cliff, and its solar panels never got the light. So the story continues with SLIM, because I think they shut their systems down with something like an hour of juice left, in order to see whether the spacecraft would survive the lunar night, which lasts for 14 days, 14 of our days, or thereabouts, and whether when the sun rose again, it would rise in such a way that it would actually light up the solar panels. And in fact, that seems to have happened, because it has been restored. They've actually powered it up. It surprised everybody. I think this was, what day was this? It was the 28th or thereabouts. They succeeded in establishing communication again. And we saw basically images. Now, the way we know that it's tilted on its side or basically upside down is that SLIM also carried a couple of little rovers, one of which was the size of a tennis ball.
Oh, wow.
And sort of bounces along the surface with camera. And I think it's that one rather than the other one. I think the other one does something slightly different, but they're very, very small devices. They were obviously deployed after the landing successfully. And sure enough, one of them has sent back a picture of the spacecraft at a jaunty angle, not the right way up, on the surface of the moon. Quite extraordinary.
You can actually see the booster pointing up to the sky.
Yeah, that's right. Yes, you can. Yeah.
That's amazing.
I saw that too. See the jet nozzle. Yes.
Yeah.
Rocket nozzle.
Will they be able to do what they want to do now that that's happened? Are they still going to be able to perform all the tasks?
Some of it. I think it will be. I think it will. What they're doing is essentially doing. Powering up the various scientific experiments and seeing what they can do. I think they've done very well with an instrument that's called the multiband spectroscopic camera, the MBC multiband camera, which essentially is a device that lets you take an image but do an analysis of the exact distribution of colors in that image. In other words, the wavelengths that are being returned, which is actually a diagnostic for different kinds of minerals and rocks and things of that sort. So, yeah, they've got stuff working. I think it's not going to be the full mission, obviously, because it's not sitting where it should have been. But the big triumph, which I haven't mentioned, is that they landed this within, I think, 55 meters of their target landing site, and that was the other real function of this experiment, to try and do a high precision landing. So didn't they call it the Moon Sniper? I think the Moon Sniper was a nickname for this spacecraft, indicating that the targeting on the Moon's surface was going to be much better than anything that's ever been done before. They were expecting better than 100 meters, and they actually got they got to half that, 55 meters from where they expected the touchdown point. That is, again, extraordinary. It's a really, really significant piece of space engineering. We're very, very excited about it.
And a very short mission. They're not planning to do more than a lunar day, is it, or something? And
I think that was the idea, a lunar day, and it might be cut short by the fact that the solar panels are pointing in the wrong direction, but they'll do what they can.
Yeah, and it might wake it up again the next lunar day, but they're not. They're not banking on it, and it doesn't matter. But it's
guarantees.
Yeah, well, you've got to give them credit for the resilience of their equipment. It's had a tough landing and it still works, which is extraordinary. One more thing in this segment, and this is a bit of a sad story. Physicist, Nobel laureate, and a man who's done some amazing things in astronomy and space science, Arno Penzias, has passed away.
Indeed, that's right. He was 90 years old due to complications from Alzheimer's disease, we're told. Horrible, horrible disease. And Arno's name is absolutely engraved on the minds of astrophysicists everywhere, because he and a man called Bob Wilson, who's still alive, still going strong, he's 88 now, they were the two who first detected the cosmic microwave background radiation.
That's right.
And they did it by accident. They were testing a receiver, a radio astronomy receiver at the Bell Labs back in, I think it was 1964. It was at Holmdel in New Jersey. They were doing experiments with this new antenna, and they found basically a continuous signal that seemed to be coming from everywhere. And famously, they tried everything to get rid of it because they thought it was interference. The most famous story is that they found a lot of pigeon droppings in the antenna. So they shoveled them out because they thought that might be what was doing it. But it didn't go away. And it turned out to be the radiation of the Big Bang, which had been predicted before that, but was not detected until that 1964 experiment. So they won the Nobel Prize for Physics in 1978. Such an extraordinary discovery. And it's actually what really put the final nail in the coffin of the steady state theory of the universe, which was in the 1960s. this Big Bang theory and the steady state theory sat side by side, and we didn't know which one was right. But the discovery by Penzias and Wilson really sealed the fate of the steady state universe and said, no, it's not that.
All right. So he was 90, as we say in Australia. That's a good knock.
It's a good knock, yeah.
Yeah. It's a cricket reference for those who are saying, what on earth are they talking about? Yeah. That's a good knock.
It's a good innings would be the way to...
A good innings is another
more formal sense. That's right.
Yeah. All I can say is thank God we don't live for the length of an innings in baseball. Okay. Your story about the pigeon poo in the antenna reminded me that when I worked for the ABC, we went off air once and we had to get a technician to go up to the satellite dish to find out what was going on. He found chicken bones in the I can't remember the name of the thing.
The feed probably.
Yeah. We'd had people up on the roof looking at the air conditioner, and they'd stopped for lunch, and they decided to take the cap off the shove it full of chicken bones, and then it knocked us off the air. Cost us a fortune to fix. But and then another time it was a spider. The spider got in there and made a web, knocked us off the air. You just never know, do you? Mm. All right.
Extraordinary.
It is. It's very funny. It's one of my favourite stories. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Yes, indeed. And thanks for joining us. Now, we're going to talk about dark matter, a topic that rarely comes up. But this is a little bit of a change of pace in the dark matter story. We're looking at our own dark matter, the dark matter of the Milky Way, and it looks like it's behaving in a way that might make our galaxy unique. And because of the way it's behaving and what's happening in the extremities of our galaxy is what I gleaned from this. What's the story, Fred? This is all very strange.
It is, and we've got to preface this by saying that anything to do with our own galaxy, and certainly its geometry and things of that sort, is quite difficult to establish because we're sitting in it. The sun is one of 400 or so billion stars, most of which are in the disk of the galaxy, and we are just one of them. So we're in a dusty disk, and we're trying to map the galaxy, and we're trying also to map the part of the galaxy that nobody can see, the dark matter halo. Why do we know galaxies sit in dark matter halos? Because we can look at other galaxies and we can measure the way the stars rotate. That was something that was it was first noticed, that the rotation of galaxies not making sense was first noticed by Ken Freeman, one of our colleagues here in Australia, Ken Freeman of the Australian National University. And then followed up, that was in 1970. I think he won the Prime Minister's Science Prize for that work. It was in the late 70s, 1978, if I remember rightly, that Vera Rubin and colleagues really brought it to the attention of the world's astrophysicists when they measured the way some galaxies rotate and discovered it didn't make sense. And so what you do, you look at a galaxy, you can measure its rotation either by using a spectrograph and looking at the starlight, because the Doppler effect, if the galaxies edge on or nearly edge on, the Doppler effect will show you the rotation. And you can actually do it, as I think Vera did, by looking at clouds of gas with radio telescopes. Either way, what you find is that instead of the rotation speed of stars and gas in a galaxy dropping off as you go farther away from the center of the galaxy, which is what you would expect if there was nothing else there other than what you could see, instead of doing that, the velocities stay flat. In other words, the velocities are always the same, no matter how far out in the galaxy you go. It's what we call a flat rotation curve. And that's what's led to the theory that galaxies are embedded in a blob of dark matter, a giant dark matter halo. Now, probing that kind of detail with our own galaxy is not easy because we're sitting in it. But with new technology, and in particular, it's the Gaia spacecraft that can measure the motions of stars very, very accurately. A group of scientists based actually in the United States. I think MIT is the main institution where these scientists work. One of them is a scientist I know, actually, Anna Friebel. She's somebody I've worked with in the RAVE project. But what they've done is they have very carefully measured the speeds of stars at great distances from the center of our galaxy. In fact, going out to something like 100,000 light years. Now, at that distance from the center of our galaxy, there are very, very few stars because, they're real outliers, because we think the diameter of the galaxy isn't much more than 100,000 light years. So if you're kind of doubling the radius of that and finding stars there, you're really looking at distant, faint stars. They're difficult to measure, but you can do. But what they found is that, yes, there is a flat rotation curve exactly as we see in other galaxies out to something like 80,000 light years. But after that, the velocities fall away and you get a fall in the rotation velocities of stars. And the interpretation of that is that the dark matter halo that actually controls these rotations is not as you would expect, which is basically a blob that's more dense in the middle than at the outer edges. They're suggesting that the middle is less dense, that it's like an apple with its core taken out. I think that's the analog that's being used in the paper that they've written, which is published, by the way, in the monthly notices of the Royal Astronomical Society. So really, really interesting. A lot of this, of course, is due to computer simulations. And I think that's the next step, is to, if you have got a falling rotation curve, which is what they think they've detected, then you've got to turn that into models of the distribution of the dark matter and try and understand why our galaxy shows that and why other galaxies don't. So that's, as you said, it's pointing to the idea that maybe our galaxy, maybe not unique, but certainly very unusual compared with the general number of galaxies.
The question obviously is why. Why is this happening?
Exactly. Why is it so?
Yes.
And we don't know the answer to that. So I think
I didn't think we would.
Well, but people don't just say, like I would, I don't know the answer to that. What they do is they then look back at their models of galaxy evolution and how galaxies form and see whether they can replicate a galaxy with a less dense center in its dark matter halo. So it's not, throwing up your hands and saying we don't know. The answer is we don't know, but we'll find out.
Could it be, Fred, that this is just part of the life cycle of a galaxy?
Yeah. Exactly. That's exactly right. So that maybe, as they model the evolution of galaxies and the dark matter halos over time, they might be able to find that this, yes, is a normal part of the process, that all galaxies do this. But at the moment, we don't know that.
Yes, fascinating, isn't it? If you want to chase that up, space.com's got a great article on it, or you can go to the Royal College thing, the
Royal Astronomical Society, yeah,
that's
the one, yeah,
and read the whole report. But be prepared to read 15,000 pages of authors.
Yep.
Yeah. All right. Let's move on to another story involving Mars, and we've spoken about this a couple of times before, but it's defied explanation, and that is that they've been detecting methane on Mars, and it's given rise to suggestions that it might still have seismic activity, it might still have some kind of, volcanic action going on, all of which have been sort of looked at with a giant question mark. Now something new has popped up to suggest these burps might be caused by something else, Fred.
Yes, that's right. Well, it doesn't actually, it doesn't give us much insight into the origin of the methane, because, as you say,
still
methane,
a mystery.
Yes, that's right. Methane could be formed by volcanic residual tectonic activity of some sort, or, more intriguingly, methanogenic microbes. If there are methane burping microbes alive on Mars under the surface, that is another possibility, and that's why it's so exciting. Because on Earth, most of the methane in the atmosphere is produced by life. A lot of it comes from cows, in fact. Now, the thing about methane is it doesn't last long. If you generate CH4, the methane molecule, put it into sunlight or daylight, and it separates into carbon and hydrogen. It doesn't last. It doesn't stick around long. So if you find it in an atmosphere, you know that there is some source that is replenishing it. And that's why why it's so intriguing. We've known about methane on Mars since 1999. Some of the detections then made from the surface of our own planet, because you can detect it in the atmosphere of Mars. But several missions that have had methane sensing apparatus, both on the surface of Mars and in orbit around Mars, have basically given us ambivalent results. You find, for example, that I think Curiosity periodically detected a burst of methane in the part of Mars where it's sitting on the surface, which was completely unnoticed and undetected by orbiting spacecraft. Only in a very few occasions have these various different spacecraft actually both been able to detect a single methane event. So why does it pop out like this? Where does it come from? And what's now happened is a group of scientists, actually I think led from the Los Alamos National Laboratory in the United States. What they've done is they've suggested that maybe the methane is being sucked out from underground by changes in Mars's atmospheric pressure. Now, Mars's atmospheric pressure is less than 1% of the Earth, so it's not much, but it does exist and it does change. Well, basically, giving rise to weather on Mars. And so what they've done is they've done a simulation of how methane might, if there's methane in underground networks, fractures of between the rocks and places like that where it might lurk. If the methane is there, what they've done is they've simulated how it moves in those networks. And it turns out that seasonal changes in Mars's atmosphere might be what actually bring the methane to the surface where it's detected. And they've actually gone a step further with this because they've predicted what might happen with seasonal changes. They basically, in fact, I'm quoting here from the Universe Today's article, which is that the simulations predict short-lived methane pulses prior to sunrise for Mars's upcoming northern summer period, which is a candidate time frame for Curiosity's next atmospheric sampling campaign. So what they're doing is they're saying there's Curiosity sitting on Mars. It's got methane sensing equipment on it. We think that as the northern summer on Mars evolves, we're going to start seeing short-lived pulses of methane. Discuss. So that's basically what's happening. They're suggesting that the Curiosity scientists should keep an eye out for this. And I think that would be great if we started seeing pulses of methane when these things are predicted. Then it would give us some confidence that those simulations are on the right line.
So it would add a significant amount of evidence to their theory that this is a Mars atmospheric pressure issue. It doesn't answer the question as to why methane exists.
No,
and
that's right.
What's producing it? So,
that
mystery remains.
That's right. That mystery remains. But it's what it's saying is we could at least suggest where the methane is lurking. If it is in fractures in the rocks and it's being pulled out by atmospheric pressure changes, and you can predict that, that will be a step forward. Even though it's exactly as you say, we don't know whether it's methanogenic microbes sitting there and emitting methane, or whether it's residual volcanic activity.
Space cows, that's what it is. Space cows. Yeah.
Blame the space cows. It's always the same
cows.
Story.
Yeah. There's actually a poker machine for you Americans, a slot machine that does have space cows. I saw it one day. Very weird. It's very strange. But we'll wait with interest. There might be more to report on this particular story.
Yes, I think so.
Is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Now we reach our least favourite part of the show.
we checked all four
No, this is good. This is
Space
fun.
Nuts.
And we do encourage questions. And we've got questions from a few individuals today. The first one being Ray. Take it away, Ray.
This is Ray Krug calling from Palo Alto, California again. I was thinking about meteor showers today. They do the Geminids, and I just heard your podcast about the new one that may or may not have passed on the 12th. I hope you guys will follow up with that. But we speak of burning these bits of like probably sand-sized particles burning up in the atmosphere. But it occurred to me that maybe these things are not oxidizing, but they're vaporizing. These are, say, a small piece of silicon or iron or something popping in the atmosphere. Before it has a chance to actually burn, as it were, to oxidize, it's going to just vaporize. So that's my question. I mean, is it predominantly one or the other, or is it both? I imagine it's a little bit of both going on. Love your show. Thank you for taking questions.
Thank you, Ray. So when we get into a meteor shower, is it oxidization or vaporization or both?
Oh, well, I think Ray's right. It's both. So the vaporization. So you basically, it's this particle hits the atmosphere, high velocity, feels the friction of the atmosphere, and vaporizes. And then I think oxidizes, in other words, burns. So that process may explain why sometimes with bright meteors, you see color changes. Often you see green, which is caused by the excitement of oxygen atoms in the upper atmosphere. But sometimes they're white as well. I think, now I'm not a meteor specialist, but I think Ray raises a really interesting topic, and I think it is true that both those processes are at play in when we see a shooting star, a meteor. And we should, he's right, we should follow up on that predicted 12th of December meteor shower. I should check with the people I know who are meteor specialists and see whether there's any news on that. And it may well be that there's still an analysis going on of what was seen on that night. But you might remember it came immediately before the Geminid meteor shower, but it was a predicted new one. So we'll talk about that again at some later date. Thank you, Ray, for the reminder.
Yeah, appreciate it, Ray. And like all, Ray, you should be aware that whenever they say, there's a discovery in astronomy, it happened a decade ago. It just takes them a long time to write the report with a quill and an inkwell. Astronomers sort of, a bit slow to take up the new tech. Sometimes.
I'm not sure that's true. True, actually. But I do, your point's well made. There's certainly to get your data into the published record, what we call the literature, it's got to be peer reviewed, and that's a process that often does take the time. And I'm not surprised. It's quite a hard thing to do. I don't really do it anymore, but when I used to peer review other people's work, you've got criteria against which it needs to be judged, and you basically need to redo the research yourself to check whether what they've done is correct. It's pretty hard work.
Yeah, sounds like a right royal pain.
It is. Sometimes they give you $20 for it as well if you're really lucky. Nice honorarium. Yeah.
Okay. Thank you, Ray. We will follow that up. I've written a note to remind Fred to do his homework.
Thank you.
And I used a real pen.
Yes.
Now,
not the same thing. My pen's red. I hope yours is a good color.
Look, mine is too.
There you go. 2 red pens. Yeah.
I'll teach you how to use one next time I'm down there. Now let's go to Rusty in Donnybrook. I love this question. This is a speculator. We've got a couple of speculators to finish off the show this week. Rusty is suggesting a solar pergola.
Fred and Andrew, good morning. It's Rusty in Donnybrook.
just been thinking about putting a sunscreen for the Earth out at L1 between the sun and the Earth. And for a 2% coverage, it would be about 800 square kilometres. Just wondering if that sort of thing using an opaque membrane would be possible for our technology in the next, say, 20 years. And 2%, I think that would be enough to make the difference we need at this stage of the game. But it could act as a solar pergola, and they could tilt to let more or less sun through. Just wondering what you think of that idea. Cheers, guys.
Thanks, Rusty. I assume he's talking about cooling the planet a little bit. Is that where he's going?
2%. I mean, what you're trying to do is put darkness onto a spot. It would have to be, well, it wouldn't have to be, actually. No, it wouldn't have to be on the equator. It would be probably between the tropics, though. But it would move all the time as the Earth rotates, because the L2 point stays, I beg your pardon, the L1 point, which is what he's talking about, that stays stationary in relation to the Earth and the Sun, but the Earth is rotating. What I don't know, so you got 800 square kilometres, I think, is what Rusty
That's what he said. Yep.
It would have to be, which is a megastructure. It's bigger than anything we've ever built. And I'd need to just do a sum to see what angle that would subtend at the Earth's surface, just to see how much of the sun's light is blocked out. But the bottom line, though, is it might be possible. It might be the kind of engineering that could be done. I'm not suggesting it will be anytime soon. I think it's beyond us for at least a century, that scale of engineering.
Right.
The question is whether you actually want to do it. Quite a few solutions have been proposed for the issue of climate change that involve this kind of engineering. I think it's called geoengineering. Basically, you're trying to change the properties of the Earth by building something or sticking something into the atmosphere. There's been, I think it's sulfur dioxide that you can inject into the atmosphere that increases the opacity of the atmosphere. The trouble with all those issues, all those suggestions, is that they're potentially dangerous because, we in Australia know all about cane toads, which were introduced with the best will in the world.
Oh, yeah.
And now, a hideous problem. So I would always counsel against too many over-ambitious projects. But I do like the sound of that one. I think Rusty's thinking is good. Putting it in the right place there. You've got a 2% reduction in the solar radiation. That's absolutely significant if you can sustain that over a long period. You might need rockets to keep the thing in its right orientation because gravitational forces would tend to disturb its orientation. And it probably would not be sitting stationary at L1. It would probably be in orbit around L1, which might mean its shadow moves all over the place. But that's not the issue here. We're just talking about the reduction of the solar radiance in one spot. And I'm not sure to what extent that affects the overall temperature of the planet, whether it's a simple 2% drop or whether there are other factors at play, which there might be. I'm not a climate scientist, although I'm an admirer of climate science. It could be the case.
If it's anything like solar panels, it'll lose a lot in the translation. So who knows? Just a side thought to that theory of Rusty's. If we built this megastructure, would that reclassify our civilization?
Oh, yeah, to the, what's that called? That scale, I forgot what it's called as a scale of classification.
Yeah, but we're at like 0.7 now, and to be the best, we've got to be at 1, and that requires megastructures.
It does. Yeah, maybe it's the first step. It would be certainly not that really, that scale is very much one that's predicated on there being other civilizations.
Of course.
If I can use the word. And we don't know the answer to that.
No, we don't. Not yet.
Well,
thanks, Rusty.
we might never know it. That's
probably. That's probably
you
the
can't
truth.
rule out aliens until you've not ruled them out by discovering one civilization.
Yeah. Okay, thanks, Rusty. And finally, we are going to get another what if from Duncan.
Hello, Duncan here from Weymouth in the UK. Question that come to mind, with research going on Mars and Venus, would it be possible to make it easier in the long run to bring the planets closer to Earth, maybe using some asteroids in the Holman transfer orbit, something like that? So maybe move Mars in a bit closer and Venus out a bit further. And also with that would hopefully cool Venus down a bit and warm Mars up a bit. Maybe even we could set up some sort of siphon to siphon some atmosphere directly from Venus onto Mars or something like that would help terraform them, both of them at the same time. I don't know. Just a thought that came to mind. What do you think? Oh, and by the way, I bought a Space Nuts t-shirt. It's very nice. I've been wearing it all about. Thanks for the good work. Keep it up.
Thank you, Duncan. Bye. I want a photo of him with the t-shirt.
Yeah, we should do.
Yeah,
It's great stuff, Duncan.
Yeah.
And
look, he's thinking way outside the box. But I have an idea on how we might move Mars. Get someone up there with a box of matches and just fire up that methane.
there's a problem with that. No
atmosphere.
oxygen. No oxygen.
Yeah.
It
You could take blowtorch then. Yeah, with that oxygen canister.
Duncan's question is, look, it's great. It's great stuff. I love the way people think about this sort of thing. And if Rusty's speculation was mega engineering, what Duncan's suggesting is hyper mega engineering or something even bigger. Because moving planets is actually very hard indeed,
Yes.
because they're big. And there's
They're big and they're set in their ways because they're so old.
So I think, it's very set in their ways. That's right. 4.6 billion years tends to make you a bit interested in routine, doesn't it? Really?
Yeah. I'm not moving.
Yes, I'm not going to move. So for terraforming, and as you know, I'm not a big fan of terraforming because I think it's slightly, off the wall idea. But if you were going to do that, I think there would be easier ways than trying to move the planets. And in particular, the high temperature of Venus and the low temperature of Mars. Yes, it makes sense because Venus is nearer the sun than we are. Mars is further away from the sun than we are. But there's all kinds of atmospheric physics going on there as well. And moving Venus to an orbit that was nearer to the Earth would not necessarily make it any more habitable, because you've still got this runaway greenhouse effect. It's a carbon dioxide atmosphere, very, very thick atmosphere. You really need to fix that. And I don't think just moving its orbit would be enough to do that.
Unless you built a really big screen.
Solar pergola. Yeah, well, that's right. That might be the trick. So, good thinking, Duncan. Duncan's thinking is always good. And by the way, Duncan, we've got some text questions from you, which we will look at down the track. Thank you for them. Thank you for this what if suggestion. And I think this one is perhaps at the more unlikely end of the spectrum of what you could do. I think planetary orbits are, you might put it that they are literally set in stone because they're rocky planets that we're talking about.
Yes, nice thinking though. Somebody will pick that up for a sci-fi novel somewhere along the line, though. I imagine. All right.
Probably you.
I'm still working on thoughts. I'm still trying to get my audio book down for Parallax. It's just I haven't had much time, and it's a hard one to do because there's so many characters in it, and I'm running out of voice ideas. But anyway, we'll keep working on that.
Good.
I'm about halfway. So
that's better than starting.
Only 200 chapters to go. Thank you, Duncan. Thank you, Rusty. Thank you, Ray. And a reminder, if you would like to send us some questions, you're always welcome to do so via our website, spacenutspodcast.com or spacenuts.io. Click on the AMA link or the little purple button on the right-hand side of the homepage. And if you've got a device with a microphone, easy peasy. And just don't forget to tell us who you are and where you're from. We always like to know what you're up to. And have a look around while you're on the website and check out the shop and all the other things. Maybe you want to become a patron. We've got plenty of those, and they've been staunch supporters of Space Nuts for a long time, and we so very much appreciate that. Fred, we're done and dusted for another week. Oh, by the way, next week's episode, all question episode 390. Nearly forgot to mention that. Thank you, Fred, as always.
Thank you very much, Andrew. It's always a pleasure. And we'll speak again soon, maybe.
We will indeed. Professor Fred Watson, astronomer at large, and to Hugh in the studio, thanks for doing the tests this week. We were testing my technology to make sure it worked, and we got it all right. And what's wrong with me? I said something nice about Hugh. It happens occasionally. And from me, Andrew Dunkley, thanks for your company. I hope you can join us on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.